So this shield is designed to be internal armor plating. So if a bullet ever penetrates all of the outer armor and gets into the frame, there are internal armor pieces that are protecting the critical components inside the robot. The output shaft of the motor is 3/4, or actually it's 7/8 of an inch. The output shaft of the motor is 7/8 of an inch, and it's hardened steel. We have hardened teeth on all the sprockets, and this is heavy hardened chain. The chain is designed to break in the event of a system failure in order to save various components within the system.
Of course, all these pods on here are modular. They're easily replaceable. So in case they do take a hit or some kind of damage, they can be easily swapped in the field with a basic minimum of tools.
The ride height of the robot is fully adjustable on all corners. We have air-filled shocks with nitrogen gas. You can run the compression ring to change the amount of tension on it. You can change the mount point at the top and also on the bottom to increase the ride height or lower the ride height depending upon the mission and the weight of the payload on the platform.
And of course we have a trailer hitch here. This is optional. It'll allow you to tow a payload behind it, and easily you can take this off and put it on a truck or put it on the robot if you need to.
So there are RJ45s that are weatherproof through the chassis. There's 3 in the back, and then on each side here there's 6 additional ports on the passenger side, and then on the driver's side there are 3 RF ports through the chassis to support antennas. To facilitate cable routing, the chassis has these cutouts with wire guides and strap-down ports for wire ties. So you can take this component off, you could replace it, you can run your wires through the fingers and then lock them down with wire ties as you run them on the outside of the chassis.
And there will be little cable areas that will go along here, little troughs that will allow the cables to run inside of an enclosed space to protect the cables.
And these are the wire guides on the front of the robot, each with a cable tie down point. These are modular and can be replaced on the system. The electronics board mounts on these rubber shocks. We have a full suspension chassis, and then the electronics within the chassis are shock mounted on a board that mounts on top of these rubber shocks. There's 3 here and there's 3 in the front of the chassis. These panels on the side of the robot do thermal dissipation of the batteries as they heat up to lower its thermal signature, and also provide additional isolation and protection from shock impulses when the sides of the robot are hit with ammunition. These 2 panels hold the battery packs in. There's essentially 8 batteries underneath of here. Each battery is wired together with a low oxygen copper bus bar to reduce the impedance of it. Each battery is independent, and it has a battery management system built into each and every battery. So there are 8 independent battery management systems running the batteries in the robot. So the robot features full Ackerman steering, and these stainless steel push rods essentially are pushed from the front on the design. This gives the robot an extremely wide turning radius from there to there. It has 0 bump steer. As the suspension moves up and down, there's no bump steer in the system, and you can just simply adjust these shafts and lock down the lock collars in order to set the toe on the suspension as well. All of the universal joints are military grade U-joints. They require no lubrication for their entire life. These are bronze with a Teflon coated socket within inside each one. This is the camera mount pod. We can replace this with other pods. It has a lot of mounting options, including an armor kit. It can hold 2 cameras in the top. The camera sensors can be color, black and white, or infrared. This top hat protects the cameras in case of a rollover. The camera sensors are then wired to a camera module that runs underneath of this chassis component here. So when the chassis is set up without any kind of armor, then there's a number of holes on the chassis. You can see these nuts on the back, that on the outside of the chassis there are weather-tight washers that protect the robot from water penetration to several meters. When we mount the exterior bolt plates on, then this bolt gets reversed and the washer moves to the inside of the chassis. All the hardware on the robot, even the internal components, are all stainless steel. Torx is our preferred screw type because of their durability in the field. There are 3 antenna mount points on the robot, each supported by a co-located type in wire RF connector. So over that type in connector we can mount a variety of radios and antenna styles. The standard set of antennas are 8 dBi gain, 2.4 gigahertz antennas to support Wi-Fi band radios. So the wheels on the robot are ATV bolt patterns. This is the standard Honda bolt pattern, which is a 4-110 bolt pattern. You can buy a variety of off-the-shelf ATV tires and rims, including Caterpillar tracks, snow skis, run flat tires, bulletproof tires, mud tires, snow tires, and sand tires to be able to mount on the robot. This way, in the local market, you can choose the tires that fit the runtime environment that you have. These motors are designed by a company called E-Tech, and these permanent magnet motors are thin gap motors, super efficient motors. Typically one of these motors would be mounted into an EV car, so it provides enough horsepower for an EV car at a much higher voltage. We're running at a little bit lower voltage, so each motor is providing a raw 10 horsepower of runtime. We have that coupled to a 16-to-1 suspension system, so 160 raw horsepower per side of the robot. We have 2 motors so that there's a redundant drivetrain, so each side can drive independently. We also use the motors to assist the steering. By having 2 independent drive motors on the rear, we can actually slow down or reverse one rear drive motor to support the turn rate that you're going to have on the front of the robot to make it turn better, and to also support traction control and anti-lock situations whenever you're on ice and snow and things of that nature.
So this is one of our armor bolt plates. And this goes around the entirety of the robot, adding additional structure. This one here goes on the front. This is made out of a 1/2 inch thick of aluminum, and it allows for modular attachment of different accessories. Additionally, we have this on the side. It can be attached in multiple different areas around the robot. This allows it to be much tougher, and also we're going to mount additional armor with shock mounting on top of this. That'll create an air gap that will almost certainly stop any small arms conventional fire.